My name is Mariama Dryak, and I'm a master's student at the University of Maine in the School of Earth and Climate Sciences and the Climate Change Institute. I'm going to be the next researcher for the Follow a Researcher program. I grew up in Alma Center, Wisconsin, working with my brother and two sisters on our organic family farm. Each morning, I would wake up before sunrise and feed the calves and chickens and pick the eggs. During the summer, I worked outside hand-picking weeds in our fields that were missed by the cultivator. I built and moved fences for our cattle to graze in, and I operated farm equipment when fields needed to be plowed, planted, or harvested. Growing up on an organic farm taught me that the earth is composed of a variety of systems that work together, much like the different aspects of the farm work together, where changes in one resource can cause effects in other resources. Even though I no longer live and work on the farm, I still use the idea of systems to make everyday decisions and in my research as a scientist. Although now I'm a research scientist, reading and writing were definitely my favorite subjects in school and what came most easily to me. In high school, I took a class that introduced me to the archaeological and glacial histories of Wisconsin. I became fascinated with the early landscapes and how Native American peoples of my home state had developed and thrived so long ago. That curiosity led me to study archaeology, geography, and English at Durham University in the United Kingdom, a place that I had found and applied to after Googling what is the best school in the UK for archaeology. That year, I began to learn about climate change in my classes about physical Earth systems, and I attended an educational outreach event that discussed climate change. I decided that I wanted to apply for an internship that focused on three things: archaeology, climate change, and it was based in Alaska. So I researched just that and found an opportunity and applied for the internship. In 2015, I was selected for the Mosaics in Science internship, which is a National Park Service program promoting diversity in the earth sciences. I worked in the Western Arctic National Parklands, which is made up of 4 National Park Service units, as an archaeological research assistant in a small team of researchers. The project goal was to investigate how climate change was affecting the coastline and the artifacts left behind by Native Alaskan peoples. While hiking along the coastline in Bering-Lambridge National Preserve, surveying for these eroded resources, I came upon an exposed permafrost cliff face of cupped ice melting so rapidly in the sun that you could hear water gushing out of the soil, forming channels, and flowing to the ocean. I was shocked by the powerful visual display of climate change and was immediately drawn to study not just the resources that were being lost due to climate change, but to the physical processes that were causing the loss of tool and bone resources in the first place. My observations of rapid permafrost melt in the Arctic prompted me to continue studying the cryosphere, or all frozen bits of the planet, specifically glaciers. This path led me to study a small glacier in southern Iceland called Steinholtsjökull for my undergraduate thesis project. I studied how this glacier and glacier system had changed over time and how changes in climate and other variables like volcanism, landslides, and flooding may have affected rapid retreat in Steinholtsjökull over the past 150 years. While studying Steinholtsjökull, I discovered a topic that really fascinated me: glaciers. Glaciers are so amazing to me because of how slowly they grow in size, over hundreds to thousands of years, yet they can be lost so rapidly due to changes in climate. I decided to continue my studies and pursue a master's degree at the University of Maine in the School of Earth and Climate Sciences and the Climate Change Institute. My current research involves using satellite imagery to measure how icebergs are melting around Antarctica. Icebergs are chunks of ice that break off of glaciers that flow into the ocean. Measuring iceberg melt can help us understand changing ocean conditions, like temperature and velocity, and how these changes might affect nearby glaciers. This is important information since melting glaciers can affect ocean circulation, marine ecosystems, and sea level rise. One of the coolest parts of my work, pardon the pun, is that we can use satellite technology to gather information that is nearly impossible to obtain from ships. Because it's so difficult to make these measurements in the field, it is difficult to fully understand the relationship between ocean conditions and glacier changes. I'm really excited that you're joining me over the next few weeks, and I'm looking forward to hearing your questions and sharing my work with you. But first, I have a few questions for you to think about and discuss. As you can see, I didn't always know that I was going to be a glacial scientist. I followed my interests, looked for different opportunities that ended up taking me to cool places all over the world. Is there something that you really want to do or an interest you'd like to explore but haven't tried to achieve it because you're not sure how? Ask a teacher or someone at home to help you search the web and try for an opportunity you really want to get. You never know where it might lead you. What else would you like to know about my research or past experiences? Thanks again for joining me on this season of Follow a Researcher. Be sure to check out our website and follow me on Twitter as I answer your questions and talk more about my work as a scientist that studies the Earth from space.